Hi, this is Jacob Nash back here with going over some uh, questions that are about Unit 1. All right, so I just decided to have my camera on today. Don't care if you know what I look like. Okay, that was on the wrong thing. That's the answer key. So now we're going right here, all right? So if you didn't see the video of me going over the content, then please watch that, but this is just going over the kinds of questions. You might want to have a calculator nearby. You know what? I'll just turn on this thing here. I really hope that let's see. I'm just gonna do this. I hope now that made you be able to see this. Yeah, so there you go. That way you can see what I'm doing. All right. I'll minimize that for now though. All right. So the table shows the survey from 7 randomly selected AP Statistics students in one high school classroom. The individuals are, well, look, I mean, this is just kind of a simple question, really simple. This isn't necessarily how easy they'll be on the exam. This is just content questions, content review questions. So survey results from AP statistics students. That means that it's the students. That's pretty easy, hopefully. All right, that's not even really, anything. The table below, okay, same thing. The data set contains how many variables basically, and which are qualitative, quantitative. Well, it's always good to do like check X with questions in statistics. So let's do check X. We'll do a check if it's qualitative. Grade. That you might think it is. No, that's not. You might think just because it's a number. It's a measurement is the only thing that is quantitative. So that's why it's not. Because is that a measurement? Well, I guess you might think so because it's a measurement of what grade you're in, but it's not. Is it something that someone like took out a ruler or a scale or some sort of thing, or it's really it's just kind of a random thing. So that things like grade, what grade you're in, zip code, things like that, they are not quantitative. Weight is. So check. Sport, no. That, no. Those hopefully those are easy because they're words. Shoe size, yes. No. Yes. So there's only 3. How many variables total are there? There's 1, 2, 3, 4, 5, 6, 7. So let's cross out the ones that don't say 7 and circle the one that says 3 are quantitative. Sorry. School administrator surveyed high school sophomores about their expectations of college attendance. One question was asked, what do you think are the chances that you'll graduate from college? Here's what they said. And that's what it is. Identify the percentage of males out of total. All right, so male divided by total is what we're looking for. All right, male, oh, great. We're gonna have to add all those things and divide it by the total. All right, here's a trick. Let's do alpha, y equals, enter. That made it a fraction. So male, let's add the male. Can I touch screen this? Yeah, I can. Sorry if this takes a long time. I don't think I can use my keyboard, so kind of taking a long time. All right, now we're down here. So that's male. So now we have to add everything. 70, 112. Whew. Any day now. Obviously, you could do this a lot quicker. Oh, this thing's blocking. Okay, I typed in. 75. Enter. Oh, yeah, is that helpful? No. Let's change this to decimal. So 456, that means 45.6. So obviously that means it's C. No, A and B aren't even percents, so that's dumb. Oh, okay. A market research company surveyed families to determine how likely they were to purchase teeny tally snack foods. Identify percentage of families with children who purchase. Ooh, this is conditional. See, the other thing was marginal. I made a video about that too, if you don't know. So that means we're looking at two things, like a combo thing. Families with children, okay, we're talking about this, that purchase. So that means it's gonna be 73 divided by, and we're gonna add all those numbers up. So, oh, we're already on that. I'll do clear. Once again, so we're gonna do 73 divided by, add those things up. Enter. Oh yeah, once, thank you. That's not helpful. Go back. It's decimal. 1.6, so about 32%. Oh, and I already said it was conditional, so it was A. Conditional is whenever it's something that basically the numerator is not really, it's not a sum, basically. The numerator is not a sum. Is it? No. It was up here. It wasn't here. All right. An animal rescue group tracks how their marketing impacts the pet adoptions that occur each year. Record of adoptions is shown. Okay, we don't need to know all the details always. Which of the following gives the evidence of association? That means a relationship between social media use and adoption of an animal. So featured on social media, animal adopted. There is a greater proportion of animals adopted when social media was used than when it was not. All right, first of all, let's see if this was true. 138 out of 216, yes. Then when it was not, yes. That's what it is. We're comparing two things. 138 out of 216, 76 out of 138. Combination of being featured on social media and being an animal being adopted occur more frequently than any other combination. That doesn't mean anything. These are the 4 possible combinations. That really doesn't mean anything. That just means that there happen to be more. That doesn't show an association. So that's why it's not that. Total of one. Oh, well, we definitely know it's not these because total number of animals, that doesn't mean anything. That just happened to be the case. All right. Student populations of 10 colleges are shown. Determine whether the mean or median best describes the center. Well, I told you on the last thing that I made, reviewing the content, that we usually use median, but let's see, just to make sure. If it's centered, then it's better to use the mean. But it's not. If you look, big gap here, right? Pretty big gap right here. Not as big, but then we're definitely going to use the median because the mean is going to be greatly impacted by that extreme score. So the mean is not affected by an extreme value. All the data is close together. That's obviously not true. So, okay. A resting heart rate is shown. Determine the standard deviation of the set. All right. Well, we're gonna have to enter our data here. So, edit. Clear. Oh, sorry. Del. All right. And look, see, there's 2 things. So that means we're gonna have to put something in L2 also. Sorry, my freaking thing. All right. Anyways, 60, 65. Oh, okay. Why did that happen? Sorry, this has frozen. All right, 70, 75, 80, 85, 90, 95, 100. And yeah, you kind of want to make sure you're doing it right. All right, L2, all right, 1, 3, 4, 12, 8, 15, 9, 5, 3. All right, standard deviation, we're going to do calc. We're going to do 1var stats. Ooh, we have to do freq-list this time. So second, list to calculate. Standard deviation 9 point, oh, sorry. We're not going to use, we're going to use the sample one. 9.27. So it's going to either be A or C. The typical heart rate varies by the mean, by average of 9.7. And then it's saying a typical one. So it would be this one, because a randomly selected, that doesn't necessarily mean that, because it could be a little more, because, you know, empirical rule. I have to pause this for a second. All right, back here. All right. It's basically now just saying, find the 5-number summary for this thing, okay? We're going to do quit. We're going to go back, and we're going to have to delete everything out of this. And once again, it would be way quicker for you. Sorry that it's taking long. Might as well just do this. Okay, I put the things in. All right, well, now we're going to do stat. 1var stats again. But, ooh, freq-list. We don't want that this time. That's going to make it different. So del, trash can that thing. Oop. Made it go over here. Clear. Bye-bye, I don't want that anymore. Okay. And so now, look what we have. All right, 31, 38, 49, 52, 65. We have our answer. All right, 70th percentile. What does this mean? I always said she was better than 70%. It's always, percentile is percent below or percent at. Salaries of 235 nurses were analyzed. It was found that the high salary was incorrectly recorded as 10 times the actual amount. After it was corrected, it was still higher than any other value. What must have changed? So basically it's saying we divided something. And when things are divided, everything changes, or potentially can. But we know for a fact that the mean had to have. Mean always changes when there's some kind of thing like this, always. So that should be your automatic choice. The other ones, you never know. It could, well, mode, definitely it's not that. Because if it was still higher than any other one, it couldn't have been the same thing. But, oh, and sorry, of course not minimum. That wouldn't change either. And the median, it could, but we're not so sure, because you never know. If there was a lot of the same value, imagine if it was like 89, 89, 89, 89, then 93, well, it's still going to be 89. Okay. Oh, wait, of course, actually, yeah, never mind. The median definitely wouldn't have changed, because we're not adding a value to the set. Okay. So anyways, what are quantitative? It was kind of like the other one. So no, that's not. Yes, that is. No, no, yes, yes. The mean number spent is 6 hours. Standard deviation is, well, that's terrible. If each time was increased by 1.5 1.5 hours. So that means we're adding 1.5. What would be the new thing? Well, we always know when we add something, the standard deviation doesn't change. So it's going to have to be something that says 2.5. The mean would change though, so it's D. And if you didn't know that, please watch the video. Me going over content. I already said that. Sample, all right. How many children reside in your household? What number was least frequent? We see that that's 4. So it's going to be 68 divided by total. Or we're going to do this again. So I almost did something that you don't want to do. I was about to add all these together. Well, it tells you what's the total. So that saves me some time. All right, that looks like it's about 4.53%. What's correct about this? Okay, well, whenever you see this stem plot, you're going to want to flip this thing over and then kind of just make your own thing. All right, there was 1 there, there was 2, there was 5, there was 4, there was 3. There are no outliers. That is true. It's skewed left. If anything, it's, well, it looks like it almost is skewed left, but if you type this in as a box plot, you would see that it actually looks like this. It is like almost perfectly symmetric. So that's not the case. Center is around 44. Well, if you were to type these to the calculator, I'm not going to do to save time. It's not what that is. The distribution is bimodal. Well, let's see the different modes. All right. Well, this is the mode. It's unimodal because there's 55 is the mode. Spread is from 38 to 67. 29 to 67. Okay, Mia been on a weight loss program. Which box plot represents set? All right, let's do the box plot. All right, I'm gonna enter the values here. Okay, now that I've had entered the values, I'm going to want to do this. I'm gonna want to do zoom. Oh, wait a second. Hang on a second. Okay, so somehow I randomly forgot to put it in the calculator. You do zoom 9, and there you go. Well, actually, you to make sure that it's on the box plot, do second y equals, and you choose which one you want. We want this. So we would say on and yeah, so we choose number 1. We're making sure that it's on. We want that kind that displays outliers, right? And then zoom 9 plots it. So, but actually this isn't, never mind. This isn't what we would do anyways. We would want to see the 5-number summary and see if it matches up because you can't tell by this screen exactly. So we need to see, all right, minimum 3, all right, minimum 5 there, minimum 2 there, minimum 3 there. Okay, we're keeping C in mind. Minimum 3 there, minimum 3 there. Okay, C, D, or E. Maximum is 16, all right, 14 there, so it's not that. 16 there, so okay, we're down between D and E. All right, the median is 8. That's not 8 there, it is there. And there you go. So here we go. This is these are going to be free response, basically. So it's showing a histogram showing the time that it takes for 22 third graders to do their multiplication drills. Look at the box plot. Did he create it correctly? Why or why not? And what is best, this or this? All right, well, first we're going to have to add this data to figure out what the real box plot should look like, right? And we're going to same old thing, same old thing. Now, this is a frequency bar graph, so we see 3 right here, so that means we're going to type in 1 3 times. All right, and then we're going to type in 2 3 times. All right, 3, we're going to type in 3 times also. And 4 only 2 times. And you get the idea. So now, same thing like with the other thing, it's not as helpful for us to just see the box plot. How about we actually figure out the 5-number summary? So the minimum should be 1, the maximum should be 10. And there are we can just do zoom 9 to make sure there's no outliers. There's no outliers, look. So back to the calc. All right, so they got their, it looks like they got their max. Let's see, minimum. All right, they got that right. Q1, that's not right. Median, that's not right. Q4, or sorry, Q3, they got that right. Maximum, no. So that's what you would say. He did not create the box plot correctly. He depicted the median as 5, but it is 4.5. So you can't just say that it's wrong. Say what it actually is supposed to be. While his minimum of 1 is correct, his maximum of 9 is not. The maximum is 10. 10 is not an outlier, as he shows. In addition, his third quartile is correct, which is 8. But his first quartile is incorrect, which is 2, not 3. All right, which would best display this data? It's the box plot. Here's why. A box plot is better to display the data because it shows a 5-number summary. It shows the minimum, maximum, median, and first and third quartiles, which gives much more information than a histogram, which simply only shows how many students were in each category. An observer could better use the 5-number summary for analysis. So there you go. Now we're going on this. A pulse rate of 20 wrestlers was recorded before and after their wrestling match. The pulse rates are listed in tables. So pulse before, pulse after. And it's asking on your own, please only look at what I'm reading because the answer is already there. On your own paper, create a back-to-back stem plot. Submit a, okay, obviously this was some kind of assignment, so you don't need that. That doesn't matter right there. Justify your reasoning, that does matter. So let me only cross out that. All right, compare contrast. All right, well, let's start out with this. Back to back. Can't talk, can I? Back-to-back stem plot. That's simply what I drew here. It's when it's like, oh, there's things on the left and the right. And you always, the lower numbers are always closer to the middle. So 8 7 7 7. But if it was over here, it'd be 7 7 7 8. And now it's basically why did I use split or non-split? Well, did I use split or non-split? I use split because look, there's 2 6s, 2 7s, 2 8s, all the way down. And let's see why. I use split stems because if non-split stems were used, then there would be a lot of data in each stem. Think about it. Look, so many 7s, so many 7s. That would be just crazy. Because there was a lot of data given in a 10 value range. For example, 95, 96, 97, 98, 98 for after pulse rates. In addition, for every overall range of the data was not very large. by creating split stems, it is easier to see where most of the data falls, in the upper or lower end of the 10 value range. And then now we're saying compare and contrast. Well, what can we do? To compare and contrast, we can use SOCs. So the before exercise data was unimodal with a mode of 67. On the other hand, after had modes was multimodal with these modes. Median was greater for the after exercise data, which was 97.5. This is center. This describes the center of the data. Both ones were skewed to the right because the majority of the data is in the lower end. Imagine, once again, now it's a little bit reversed for this, but just imagine if this is kind of flipped over. Instead it's put like this, so that it would go to the right if you put a skateboard down that. That's what I would say. Same thing with this. It would go to the right. Yeah. Extremes are to the right. Yeah. The range of the after exercise data is greater, which is 62 compared to the range. So this has to do with spread. That had to do with shape, what I just said before that. The standard deviation was also greater. There was no outliers, but there was for the other ones. So there you go. You can see I used SOCs to do it. It wasn't necessarily in order, but I still did. All right, now we're going to go back to this where you don't see the answers. Okay, it wasn't going back to it for a second. All right, continuing. Do we have that much questions left? All right, not really, luckily. Okay. IQ scores for adults are that, okay? Well, that means the mean is that, and the standard deviation is that, okay? What percent of people have scores below 120? Oh, guess what? We are going to have to use our calculator technique. So here's what we have to do. Second, vars. Oh, it was not. Second, vars, normal CDF. Oh, if you see this, that's not good. We have to do mode, and then turn that stupid stat turn that stupid stat wizard off. Go down, 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 down. Stat wizard off. Sorry, stupid wizard, we don't need you. Okay. Back to what we were doing. Second vars, normal CDF. Now we're going to type in it's below. Okay, well, I said in the video before, if it's something below, we would do minimum, and then the z-score of whatever it is. So we're not going to do minimum 120. Minimum z-score of 120. So the z-score we know is this. So 120 minus 120. Oh, wait a second. Oh, yeah, sorry. Okay, so don't think that because it's 0, that's bad. We're going to just do the minimum. Okay, the minimum is 20. And then wait a second. It's saying, oh, I'm sorry, there's something stupid thing is in my way. The age 20 to 34. So actually, we wouldn't say 20 because that 20 is the minimum IQ that there can be. The minimum, okay, wonderful. Couldn't do delete. The minimum, since we don't know, we can just say negative 99, comma 0. Ooh, 50. So whenever you don't know the minimum or maximum, just do 99 or negative 99. Okay, and Sagan got 1200 on the SAT. That thing has a mean of that and standard deviation of that. Andrew got a 27. This thing has a mean of that, standard deviation of that. Which is better? Well, all we have to do is compare the z-scores. So let's find the z-scores. All right, I'm about to smash. Okay. Keeps moving. Why does it go over there? All right. And of course, I have to anyways do this. Okay, so we know the z-score is going to be like x, 1200 minus the mean divided by the standard deviation. That's the z-score for that. Oh, and of course it puts it into freaking fraction. All right. So then the other one, let's bet it's going to do fraction again. Yeah. All right. So 2.2 is what the first one. Yeah. And then 1.4 second one. Second person. So obviously that means that Sagan did better. Sagan scored higher than Andrea. Sagan's standardized score was, I'm not reading it. Hopefully you can see that's correct. Sagan scored higher than Andrea. So obviously that's not right because the highest thing for both of those isn't the same thing, is it? This one's wrong because 1.4 is obviously not higher than 2.2. Yeah, that's not right either because it's not the same thing, not the same thing. Okay. All right. Alex's, here's where we use the table, all right? Alex's home run distance is normally distributed with a mean of this and standard deviation of this. I'm just getting lazy, so I don't feel like it. He wants to find the probability of at least 375 feet. So at least, that means basically this. He calculated z-score to be negative 1.21 and looked it up on the normal probabilities table. He found the probability to be that. Determine whether he made error. Well, we got to first find his z-score. Okay, so same thing. So it should be negative, shouldn't it? Because he was below the average. The day that this doesn't put it into a fraction, I would be happy. Okay, so he did get the z-score right. So z-score, yes. But what about this? All right, let's look in here and find it. All right, we'll have to go to negative 1.2. Right, that's right here. And then this, right? And we'll find where they connect, which is right here. And then you might be tempted to say that he did it right. But what did I say? I said that's the percent that it can be below. He's trying to find that it can be at least. So we would have to do 1 minus this to find it. Or if we change it to percent, then 100, you know. So yes, he made an error. So he has to subtract the probability of 1. It would be from 100 if you are made it into a percent. I already said that. So there you go. All right, what's the following statements that are true regarding the central limit theorem? Standard deviation decreases as sample size increases. Yes, I said that was one of them. Sample size large, yes. Dependent, A, no. Independent, not normally distributed, no, that's not right. So we always should do check X whenever you have those stupid Roman numerals. So the answer is E. Oh, not done. I thought we were done. Mean weight of chicks is this. Standard deviation of this. Z-score of this. How much does it weigh? That means we're trying to find X, or the value. So that's just like kind of, you know, your common algebra. So let's plug things in. Plugging this in for Z. Plugging, we don't know X. We're plugging this in for mean. Plugging this in for standard deviation. And we would just cross multiply. I'm going to use my one that I have because I can do it quicker. 1.25 times 0.4. So we're cross, like I said, we're cross multiplying. So that would be X minus 1.3. Add 1.3. 1.8. Dang. There you go. And that's it.